Hey, I'm mosgrom, and this is my second in 3 videos about modding TAXINAUT. TAXINAUT is written in Java, so to be able to mod TAXINAUT you have to learn a little bit about programming in Java. And the goal is to get you set up with a working starting point that is a Java development environment called Eclipse and a mod for TAXINAUT loaded into it that you can then tinker with. And there are 3 videos. The previous one was the basics of Java. This one is programming in Java with Eclipse. And the last one, the third one, will be where we create a mod for TAXINAUT in Java using Eclipse that will add a planet to TAXINAUT. So this one, programming in Java with Eclipse. So we're going to download and install Eclipse, and I'm going to show you how to use it. A little disclaimer: I've used everything mentioned here myself. For more than 15 years without issue. Eclipse has been around for 20 and was originally developed by IBM. That said, you follow any instructions given here solely at your own risk. Specifically, you agree not to hold me responsible for any damages or liabilities resulting from you following any instructions given here or from using any software mentioned or referenced here. So with that out of the way, I'd just like to point out that this document you can find at www.mosgrom.net/taxinaut modding taxinaut.html. A link will be in the description, of course. And let's get on with it. Eclipse. In the previous video, I used a set of command line tools called the JDK to compile and run our Java application. We created a little application called person that could, all it did was it said hello on the command line. It printed out hello, I'm Lois, or something like that. These tools are however very bare bones and don't provide much of extras. So instead we will start using a much more comfortable application called Eclipse. Eclipse is an integrated development environment, or IDE, for programming in Java, and contains the editor, for which we previously used Notepad, the compiler, we used Javac for that, and many other tools all under one user interface. You can download the latest version of Eclipse for free from the Eclipse Foundation website at www.eclipse.org/downloads. I've already downloaded my version, so I'm just going to take us through the install process now. So here's the installer in my downloads folder. I double click it. Then we pick Eclipse IDE for Java developers. Here we can set, among other things, where we want Eclipse to be installed, what folder. I leave it as is here. Make sure you, keep create start menu and to create desktop shortcut so you know how to start it, you know where to find the icon to start it. Anyway, let's install it. And then we accept the license agreement, of course. Okay, this might take a while. I'll just pause the video for now. Okay, so we get this trust artifact. Just click unsigned stuff. We trust it. Trust selected to continue the installation. Installation completed successfully. Now just click launch. Okay, here you get to pick a workspace. Your workspace is the directory in which all your projects and their files are going to be stored. So that means class files and .class files and .java source files, among other things. So I'm going to create a new one just for this video. What's important is that you will know where to find this this workspace and these folders. So you can change it to something you like, or you can leave it as is. Just make sure you know where it is and that you can find it later through File Explorer or something. So I'm going to put mine in here, and I'm calling it I create a new folder called modvid workspace. Modding video workspace, basically. Select folder. Launch. So welcome to Eclipse. I'm just going to maximize it. You can click this welcome message away. If you want to find it later again here in help, well, you can click welcome up here and it will reappear as you see. So I'm not going to go into, well, maybe shortly, all your project files and your whole project file structure will be shown roughly here. Here you will see things like errors and messages and output from programs. Here you will probably get some outline from your classes, what methods and member variables are declared on it. And this main area here will be the editor, which previously was Notepad. So we're just going to create a new project and we'll call it game. So I'll go into File, New, Java Project. Project name game, and just be sure down here create module info Java file, just uncheck that for now. It just makes the demonstration a bit more complicated if that's on. So and then we just click finish. So we have now created a project, and here in the left, as you can see, there's a little game folder thing. I can open that up, show some things already. SRC is our source directory in which our .java source files for our project will be stored. So let's see. So we'll add a class also called game, because our application is a type of game. We add a game class. New, sorry, to do this more clear. So I right click on source. You can right click on game, I don't think it matters. I right click on source, new, class, and type in the name here. I use a capital letter, that's kind of standard in Java, capital letter. Classes start with a capital letter. And then package. Packages are a way to group certain collections of classes, and also a way to identify what applications classes belong to, or what organization has made them, etc. For example, if Google had some classes for their Chrome browser, I don't think that's not in Java, but let's pretend it is, they might have com.google.chrome like this, and all the classes of the Chrome browser will be under this package. It works like a directory structure. Com will be a directory, and that will contain a Google directory, and that will contain a Chrome directory. We'll see later in the source folder that that's exactly replicated like that. So it's just a way to organize different classes in like a directory like hierarchy. So for us, I'll use net.mosgrom.mosvid. Let me just check here. So I have it the same as in the documentation. What did I use? Package net mosgrom modvid game. It's good I checked. Mosvid.game. So that will be the package our game application is under. Right, now just click finish. There it is, our first class, the game class and you see it here typed. Remember, this is just plain text. It just shows more fancily now with colors and stuff because it's in the Eclipse IDE. But here you can see declared that it's in package net.mosgrom.mosvid.game. And you can see it here as well. It doesn't show this as a hierarchy. It can, if I go into here. Where is it? Show, no. Oh, here, package representation, hierarchical. Oh, it did not do it? Well, that seems to be bugged. That you normally show it as a, you know, like a directory hierarchy. Now it just shows the whole package name as one folder. Anyway, if you look in your workspace, so I'll look in mine, which was in Jasper mod video workspace. See, we have a folder here for the game project. We click in there. We have sort of, just do it like this maybe. See, we have the same source folder here as well, with some other folders. The bin folder will contain your compiled classes. So if we go into source, you see net, that first bit of the package, the net package, mosgrom package, mosvid, game, and underneath here are game.java source file, right? Same as this. If I open this with Notepad, you see it's the same. I hope you can tell it's the same code. It's the same file, right? In the bin, you see, probably also the package is recreated, and already a game.class file there. And that's one of the benefits of Eclipse. As soon as things are changed or added, it immediately automatically recompiles. So you never even have to invoke the compiler. That just happens automatically. So we have our first class game. Now how do we run this? Normally we right click on the first time we do this. We have to tell Eclipse what class to run. So we right click on the class there, game.java, and then here, down here, run as. However, at the moment, there seems to be no option to run it. We can open a run configuration, but won't get into that. That's of course because we don't have a main method yet. So just as before, Java needs a main method to be able to run, as in to know where to start running. So public static void main, our familiar little boilerplate here. So a main method with no code in it yet, just like before with the person class. Now if we right click here and go run as, see it says one Java application. It knows we've added a main method. So we try that, run. Of course it does nothing because there's no code in it yet, but there are no errors or problems. So let's add our ubiquitous system.out.println hello world, you know, the usual. And now run it again. You can again right click here, run as Java application, but up here now this little button will also run the game. If you click the little arrow next to it, if you have different classes that you can run and you ran them before through Eclipse, they will show here. And you can click them like that, select them, else it will rerun the last one you used. So I'll just click the button here. And it opened up the console here, which is the same as the output on the command line, basically, that we saw when we did the person class, person application with the command line tools. And it says indeed, hello world, it is printed to the console. Right. So that's our first class. Let's see, what's next? Right. Now often, or always, when you write programs, you don't write everything from scratch yourself. You use things that were already there, created by other people or organizations. So there is bits of code. Well, not bits of code, there's things you can use programmatically that are already accessible to you. Or you can add things to your project that make it so more things that you can use in your program are accessible to you. These types of things are usually called libraries. And in Java, of course, they come in the form of other classes. For example, string here is a class that comes standard with the Java system library that's already available to us. If you remember, a string is just a sequence of characters, a bit of text. System is a class that also comes with the Java system library. And that has all kinds of things in it we can use. You can see here, for example, already in your project tree, the JRE, Java Runtime Environment System Library. If we open that up, we can see all these modules under here that are already accessible to us. We don't have to program all this stuff. So for example, the string class is here in the base package under java.lang. That's its package. The package is declared in where our class is declared in net mosgrom mosfet game, that package. The string class is declared in java.lang. If we go down here, where is it? Here you see the string class. You can open that up further and see all kinds of things that are methods and member variables, which they also call fields, by the way. It's maybe easier. That are declared on there, like what? Like join, to join two strings together. All kinds of weird stuff. Concatenate, that seems the same, but whatever. Turn the string into a set of bytes. The length of the string, a method for that to return the length. Blah, blah, blah. You can see all this here. Now this generally you won't use to find out what a class you're using does. The handy thing is, when you use something, let's for example, we wanted to open a window in our application. Now I know, I just know that in Java there's a thing called frame that represents a window in your application. So I just type frame f is new frame. Now it will underline this red, and normally when you see that, that just means that if I save it, by the way, you can see this. The problems now is a red thing. In problems you can see frame cannot be resolved to a type. It just means frame is from another package and we have to import frame to be able to use it. Yeah, it's a way of linking that class to our application, I guess. If we hover over it, probably Java will give, or Eclipse will give a solution there. 7 quick fixes available. Import frame, and it says that java.awt, that's the package it is in. So if we just click that, import frame, see the error is now, if we save, see the errors are now gone. There's a warning, but that's okay. Warnings don't prevent your application from running, and often don't even matter. But the value of the local variable f is not used. It just means we've created a variable here and then we do nothing with it further on. So anyway, let's just add some code. Now, I hope you remember f is a variable, so that's refers to a particular instance of class frame that we can then use in our code underneath here to do things with by calling a method on it, or querying a field on it or whatever. So if we type f dot, as you can see in Eclipse now, it opens up this drop down that shows all the available fields and methods on this instance of frame on f, and I can walk through that with my cursor keys, and there is loads on frame. So to get a more clear idea, probably you would want to maybe look at the documentation for frame. That's available online. Sometimes Eclipse also can show the documentation here by hovering over things, but for third-party libraries, so other libraries, that doesn't always work correctly, regrettably. That's been bugged for a while, I don't know, but you can also look it up online. For example, for the Java standard library, let me see, I have a link here in my accompanying document, Java API documentation. If you click on that, you get a web page with all the different modules and from there the different packages in that are in standard Java. So for example, our frame one, we can search for it here, for example, and type frame. And there it is at the top, Java AWT frame. Click on that. And here's the documentation for the frame class, which represents a window. It's a frame is a top level window with a title and a border. And it explains a lot of things about it, how you use it. And if you scroll down, it will show all its variable members, fields, its constructors, you know, how you instantiate it. For example, this one here, right? That's what we're calling here. That constructor, to create an instance of it, of the class. And other methods. So what we're interested in is a method called setSize. So I'll do this again, f dot, I'll just type set, and see, and automatically the list updates with things that start with set s. So now we have set shape, set size. And you see there's two different ones. There's one that takes a dimension type parameter, so something of class dimension, or you can just enter the width and the height, int width, int height. Int is a type for a integer number, so a whole number, like a counting number, positive or negative, not fractional. So we'll use that one because that's the easiest. So set size, and I'll make it 100. I'll make it 500 by 500 pixels. If we run it now, it won't show anything. I know you have to do f.set visible and then true. Right. This is just a little demonstration. So let's run this. Okay, here's our window. Okay, I'll have to close it through this because you have to create code to use the little close button in the top right corner. Anyway, so that's how I've used now the frame class from the standard system library, right? Now you can also add libraries that do not standard come with Java, and for the purposes of this video I've created a little library called GameLib, which is like supposedly a game library. It's like a couple of lines of code. It's just for the purposes of this demonstration. You can't use it as a game library. Well, you can do with it what you want, but I think you get my drift. So that library can be found as a jar file. Libraries in Java normally come in the form of .jar files, and you can find the link to it again on the accompanying website. Here in the text it says gamelib.jar, the game library used. So I'll download that just by clicking on it. So that's now in my download folder. So if I go into downloads, here it is, gamelib.jar. I just right click, copy it, and copy it to my workspace, to a particular point in my workspace. I'll show you. Where is it? What fit workspace game? What I'm gonna do is I'm gonna create a new folder here called lib for libraries. You can do it differently, but it's not essential that it's called that or anything. So now I have a lib folder. Go in there and I'll paste my gamelib.jar in there that I downloaded. I'll place that in there. So that's there now. So now here, as you can see, we don't see that lib folder yet. That's a bit of a quirk of Eclipse. You have to right click on game here on the top level on your project and click refresh. Maybe that's handy as well, I'm not sure, but that's how it works. And as you can see, here's the lib folder with the gamelib jar in it. However, now our program or our project still doesn't know anything about this, or it isn't really connected to our program yet. For that, we have to put it on what's called the class path. So, or the build path, also referred to. They're two separate things really, but I won't get into that. So for that, you right click on game, then choose here build path, and then down here configure build path. Now in here we go to libraries, this tab here, libraries, click on class path, and then add jars. Now, as you can see here, you can see the same tree structure that you can see here. So you just go into the lib folder there and select game lib.jar that we just downloaded and placed there. Click OK, apply and close. Right, now we've added that little game library as a library to our program. The documentation for this library can also be again accessed through the accompanying website here, GameLib documentation. If I click on that, you get a similar website as for the standard Java library, except with way less in it. It only has one package, net mosgrom modfit GameLib, and that package has two classes in it, a ship class and a space class. And it says space is the main game world, a space in which ships can move around. So what we'll try to do is create a space. Let me just click on here where it says more. You can see methods on it and stuff, but we'll get into that in a minute. So let's just create an instance of space. That's going to be our game world. Space as, or will I just call it space? No, I'll call it as. Space as is, how did I do it in the document? Just, I'll keep it the same as how I have it here on the website. Game, oh yeah, I did call it space. Sorry, I'll call it space, that's the name of the variable. A variable of class space is new space. Now again, it's red. If I save it, it will actually show the error. Space cannot be resolved to a type because it has to be, the package that space is in has to be imported first. So hover over it, and there it says import space, and then it says the package net.mosgrom.modfit.gamelib. So we'll click that. Now if for any reason you hover over it when it's red and it doesn't give that fix import, you can just type this in here yourself. You see how it added this? Import. It just imports the class, so the package, full package name it gives, and then dot with the name of the class, space. Right? I hope you get this bit. So I don't need to do that the way I just showed you. You can also type it in. Don't ever forget, this is just plain text. All these handy things are not necessary if they're not working, or you can just type it in by hand, like in a normal text file. This is a normal text file. So we now have an instance of space anyway. It again gives the warning that we're not using it. Let's just try and run it. So just click on the run button. Well, it opens up a window with blackness, the blackness of space in it. So that's handy. We can close this one as well. So that's already done. So what can we do with space? Well, one way to find out would of course be if we did space dot. Now we can see all the methods on it and the fields that we can access on the space variable. That sounds a bit odd, space variable. Let's see. Right, but maybe handier is to look at the documentation. Because also this won't always work correctly in Eclipse. So in documentation here, let me look it up again. Where is it? GameLib documentation. We'll go into ship. Let's see, the constructor here, create a new ship at core. Oh, that's ship, sorry. In space, what can we do with space? The main game world is space in which ships can move around. You can add ships to it by calling add ship. So if we go down here, the field summary, constructor summary, method summary, there's a method here, add ship. Add a ship to this space. I can click on it, see a bit more. Add ship, yeah, add a ship to this space, and it needs as a parameter some instance of ship, something of class ship. Now, as we've seen, there's also a ship class indeed in the game library. And we can construct it by a simple regular constructor. We can create an instance. So we'll do that and add that to our space. Ship is new ship. Now again, we get the red underline. Save it first. Then hover over it. Import ship. And if that doesn't work, just type that in there. Import blah blah dot ship. And now we're going to add this ship to the space by space dot add ship, just like that. Now the ships are very simple, of course. They're made, they're just little squares, that's all. And in this case, white little squares. So we'll see what it does. Run. Here in the top left corner, which is the 0, 0 coordinate, there's a white square. That's it. It's not doing anything. Right. So now I have a space with a ship in it. Okay, what's next? Sorry, I have a little thing here. Yeah, now comes the crucial part. When you create a class, you can use other classes in it as part of it, right? Classes that all somebody else made or added functionality, etc. Like here in our game class, we're using the space class and the ship class. But another way to add functionality to a class is by inheriting functionality from other classes. Classes exist in inheritance hierarchies, which basically means, think of, for example, that you have a class called plant, and that can do several things. It has a method called grow, for example, right? But now you want to create a tree, and on a tree there's also branches, so you want to add fields branches. What you can do is you can have the tree class inherit from the plant class. So that will also mean that the tree class will be accepted by other code as being of type or of class plant, because a tree is a type of plant. The way you do that is, no, let me say this differently. We're going to do this as well, but we're going to do this with ship. So we're going to create our own type of ship. And the first ship I'm going to create is a player ship. So we're going to add a player ship to our game project. So I right click here on the net mosgrom mosfit game package. Here, let me just close this. And then go into new class. And we don't have to fill in the package again. And we do call it player ship. There we go. So now we have a player ship class. Of course, if we now try to, let's erase this, we can instantiate it. Player, let me just check what I called it in my player. I just called the variable player. Player ship player is new player ship, right? Now we have an instance of class player ship assigned to the variable player. And then we add that to space. At least if we try that, it will be an error. The method add ship in type space, sorry, is not applicable for the arguments player ship, because player ship is not of ship class, right? It's not a type of ship. What we can do here is player ship, have player ship inherit from the ship class. That's already in the game library, in GameLib. And the way we do that is by typing extends ship. Now again, this will red underline because in this class, it doesn't know what ship is yet. We have to import it again. And ship cannot be resolved to a type. So hover over it, import, and now it's fine. So now we have a class player ship that is also of class ship. So anywhere where ships can be used, this thing can be used, right? And this class in its code of its method can use anything that's defined or that's accessible to it, and that's defined on the ship class. So now here you see there's no error now. We can add player as a ship to the space, right? Let me just remove this. We're not using this anymore. So all classes, in fact, are already part of a hierarchy of classes. First of all classes implicitly inherit from the object class. And you can see that, for example, here with game. No, let's do it here in player ship. If I add a constructor here, or some method, void blah, this is just to show you. If I type this is a variable that's always implicitly declared on a class that just references the current instance of that class. But if I do this dot, you can see there's already, oh yeah, this isn't a good example, of course, because it has ship. Right. I was going to demonstrate how on a simple class with nothing in it. Yeah, let's create a second class. We call it new class NPC ship. We'll need that anyway later. Now, as you can see, this doesn't extend anything yet, right? But if I create a method, blah again, and I call that variable that refers to itself, this dot, there's already things on it. Well, there's blah on it, of course, we just defined that, but there's like clone, equals, finalize, get class, hash, all these methods already. These are methods that are defined on the object class, which classes always, at least, implicitly inherit from, directly or indirectly. Now, the way you can see this in the documentation as well. Like if I go into, for example, let's go back to our frame. So that was in the desktop module, Java AWT, that stands for Abstract Windowing Toolkit, by the way. And we go down to the frame class, we can find it, frame. Here at the top you see the module it's in, the package is in, class, frame. And then you see this here, sort of like a tree structure. And at the bottom you see Java AWT frame, that's this class. You can see that frame inherits from window, and window inherits from container, and container inherits from component, and component inherits from object, that class that all classes ultimately inherit from. So frame is a type of window, and a window is a type of container, and a container is a type of component, and a component is a type of object, and so on. If we click, for example, here on object, we'll go to the documentation for the object class, right? And you can see here all the methods defined on an object that we saw before when we did in blah, we did this dot, you know, we saw clone, equals, finalize, get class, all this stuff. That's already there. So we'll leave our NPC ship alone for now. So we have a player ship that extends from ship, and we've added that to the space. And if we run it, it does exactly the same thing, right? It shows the little white ship there, white square at coordinate 0, 0. Right, but we want to do it, have it do something else. Let's see. We'll also, yeah, let's also add the NPC ships to it already. So I'll create 2 instances of NPC ship, that class we just created. NPC ship, oh, what did I call the variable in the documentation on the website? Sorry, I called it NPC1 and NPC2, right? So NPC1 is new NPC ship, and NPC ship, no, I will add it, space dot add ship NPC1, save it. As you can see, it's red because NPC ship isn't a ship yet, so we also must extend ship, right? Like with player ship. It's just a different type of ship now. Right, and now everything is fine. If we run it, you will just see still one white square because they're all over each other. They're all at coordinate 0, 0. But they're being drawn over each other. We'll add another one, a third one, or a second NPC ship. NPC ship. NPC2 is new NPC ship. Space add ship NPC2. Right. Run it again. Right, there's now 3 white squares being painted over each other. They're all sitting there in the corner, all the 3 ships, the player ship and the 2 NPC ships. Right, so now we want them to do something different. For example, we want them to look different. So instead, we're going to make the player ship a... What will we do? Let's see, how did I do it in the player ship? Right. We'll make the player ship a yellow rectangle. Now, the nice thing is, when you inherit from other classes, the methods that those classes already have defined, you can use them, right? So, for example, if I had a method here, blah, let's see in the documentation what's defined on ship. To the documentation here. Oh, that's the wrong one. That's the Java. No, the GameLib documentation. Go into the ship class. And for example, it has like set course on it. A method called set course. We can use that here, right? I can just type set course. And if I control enter, that tries to autocomplete. You can already see there's something there. Right, this compiles just fine. Because this method, although we haven't defined it here in player ship, is already defined on ship. So we can just use it here because player ship is a ship. But next to that, we can also provide our own version of set course by what's called overriding the method. And maybe in the documentation here you saw there is a method on ships called update. Let's click on that. Update, public void update with a parameter of class graphics. Update the position of the ship and draw it. So I'm gonna override the update method to provide my own drawing. Oh, so an easy way to do that in Eclipse is you go into source, override, you can just type it, right? Let me just say that first. I can just go public void update graphics G and import the graphics. I won't do that now. Right, we have now overridden the update. Often we put a little tag over it. That can be handy. I won't explain why. It's not necessary, but it's handy. That says add override. But another way to override methods or to have that code just generated, you can go into source, override, implement methods. And then here, see, I can see the other classes in the inheritance hierarchy that player ship inherits from. I can see ship, and down there I can see even object. I can override methods in object, like for example toString that create some representational text for this object or for this player ship in case. I can override that. So I can override the update method. So I check this, update, press OK, and it just generates the code already. Right, and here it has a little comment. I think I explained that before, this green and with these slashes. This isn't part of the code. This is just some text for you to explain your own code with. It's called a comment. The compiler will take that out or will ignore that. Basically, it's not an programming instruction. Anyway, I'll remove that to do auto-generated method, whatever. It also generated this. You know how we had this variable and we could see all things, we could access all the methods on this class through that. You don't need to type this, but there's also an implicitly declared super variable or member on every class that refers to the class that the current class inherits from. Often called it superclass. A class inherits from is called a superclass, and a class that inherits from something is called a subclass. So with super, I can explicitly call the version of update that's declared, or that's defined, sorry, in the ship class. We won't do this anyway, so we'll just remove this. But that might have code in it you want to reuse in your own version, right? So we're gonna draw our own ship in this. So for drawing in Java, you use the graphics class. At least that's what we're gonna do now. So we'll do g.fill, and you already see what's available, fill rect. And now we need to know, so fill rect needs, let me just see it here. It needs 4 arguments. It has 4 parameters, the x coordinate, the y coordinate, the width, and the height. So x and y coordinates are the top left corner, right? So we need to find out what the coordinates of the ship currently are and draw it there. Now, if we go back into the documentation, you can see that ship, are we in ship? Yeah, ship has a method called location that returns something of class point. It's just a coordinate. So we'll use that. We'll go location, that's a method that's defined on ship, and we call that method, right? And then it returns a point. Now I could do this. I could go point P is location like this. Sorry. Just have a little drink there. And then import point. Import point. Let me just pause the video for a second and sort my voice out. Okay, I'm back instantly for you, of course. So I could do it like this. You know, the point is returned by the location method there. I put it in a variable called p, and then go p, sorry. For the x coordinate we'll use p.x, and for the y coordinate we'll use p.y, and then for width, I don't know, 32 by 32 pixel rectangle. And we could do it like this. And if we now, oh, I have to set the color on it as well. So you set color, yellow. Do it like this. So it will, you know, paint a rectangle at location X, location Y of 32 by 32 pixels. Here, I'll just show you. But probably you won't see it because it's painted underneath the NPC ships, which are still white, which are the same. If I make it bigger, actually, you'll see it here. I'll make it 64 pixels. Right, if we run it now. You see it underneath there, the yellow player ship. Anyway, you can do it like this, but what I'm going to do here is I'm just going to call location here like this, and I can immediately use the returned value and get the x coordinate of it. I hope you understand. I did it like this in the code on the website, so I want to keep it the same. I probably should have done it the way I showed there. This is easier to understand, but right. So I'm just calling location here, and on what's returned, I get the x coordinate. And then I call location again, and on what's returned, I take the y coordinate of that. I'll return this to 32. 64 is a bit big. I don't know. Does that matter? But again, to keep it the same as the code as it's on the website, remove this. Right. So now we have the ship yellow, and we'll do the same for the NPC. The player ship is now a yellow square of 32 by 32 pixels. For the NPC ships, we'll use red circles. So again, here in NPC, I go in here, source, override, implement methods, and we override update again, in which we update the position of our ship and draw our ship. Erase this stuff again, and this time we'll set the color to red. G.set color to color.red, and we'll create a circle. G.draw oval, and again I'll use location.x. Circles. This method uses the way where the top left corner of a circle, blah blah blah. Just go with me on this. And the circle will have a diameter of 32 as well. 32 pixels. So this class definition doesn't know what color is yet, so import color. So it says there, input Java AWT color. Yes, that's all good. And we'll keep this the same. I think I used like this. Anyway, let's run this. Oh, I used the wrong method, sorry. It's not draw oval, that just draws the outline. We want fill oval. My bad. Fill oval. You see, now we have the player ship and two red circles that are the NPC ships displayed over it. Now we want the ships to move. The handy thing is, ship already includes when we go back to the documentation here, a set course, and also a destination reach method, and an update location method. We can use this together to have the ship move. Now for the NPC ships, we're just gonna have them move randomly, and whenever they've reached their current destination, they will set a new course. That's what we're going to do. And of course I could, for example, here, let's say we wanted to move NPC 1 somewhere, then at the bottom here I could do NPC 1 set course, the destination, let's say to coordinates 300 300, new point 300 300. What the point, because the destination must be specified in the form of a point class instance. And what else? What was the other thing? Speed. And the speed is in, you see that in the documentation here. When we go to set course, it says for ship set course to destination at speed pixels per millisecond. Oh, let me close this. I just happen to know 0.2, for example, is a nice value. And let's run this. Nothing. All right, sorry. Now what I've forgotten is the update. If we look at the documentation, where is update? Update the position of the ship and draw it. At the moment we're only drawing it, so we still have to update the position. And the way we can do that is, again, ship. The ship class already provides a method for that called update location. And for example, find it by this dot update. See, there it is, update location. We can see it here in the documentation as well. Where is it? Up here, update location. Oh, it's at the bottom here. Updates the coordinates returned by location to the latest position of this ship. This is meant to be called from update before this ship draws itself. So if we just here call, we can do it like this, update location. That's exactly the same here. I'll just run it. Oh, it asks me to save it. See, there it goes. And then it just ends there, right? But this is exactly the same. Oh, let me just close this. As not using this. You don't normally use that. I won't go into when you do. So if we run it again, it's exactly the same. So we could do it like that, right? Call it here once. But what I want to do is every time it has reached the destination, I wanted to pick a new one. Let me just clean this up a little bit. So in MPC ship, in the update method, update location, it will call that every time update is called. Update will basically be called every time the screen is drawn. So it will update the location according to where it's traveling and then draw itself every time the screen is drawn. You know, maybe 60 times a second or something, 60 FPS, whatever. Anyway, update location, we want that to be called, sorry, no, that has to be called every time, right? Whenever the screen is drawn. But we want to set a new course if the destination is already reached. So for that we can do this. If, that's a conditional statement, I won't go into it, you probably already know a bit about this. If destination reached, because that's a method on ship, you can see here, right? Destination reached method. Where is it? True if the destination of the last set course has been reached, false otherwise. So destination reached is a method on the ship class that we can use here from the MPC ship class. If that's the case, then you set a new course. Then we do set course and then to somewhere else. So how do we get an interesting destination here? Now that's where a second part comes in. We can ask space, the space class. Let's go back to that. Or a, where is space class, or a random location. So we just set the course to some other random location for the MPC. Very advanced AI. Here, this method, point random location. We can call that on space, random coordinates in this space. But we don't have any access to the space here. It's not automatically added to the ship, or the ship doesn't have access to it. So how do we do this? Ship has, where is it? Where is ship? Click here, ship. Here's the ship class documentation. As a ship added function called when this ship is added to a space, and as a parameter it will pass the space that the ship has been added to. So this is a function that's already on ship, so also available to MPC ship, and we can override it to do our own thing with it in there, just like with update. So I'm going to add that above here, sort source override implement ship added, and remove this stuff, and see here it gives us the space as soon as the ship is added, and we're going to store the space in a field, in a member variable. So we'll also add a member variable called space like this, and now in here we can do space equals s. So we'll assign the space that's passed here to this member variable, which we can now access here, right, in everywhere in our code in MPC ship. I hope you get this bit. So one moment, sorry, something required my attention there for a second. What was I saying? Set course, yeah, we need some kind of destination. We're going to get a random location from the space class, or from the space the ship has been added to. This will be called whenever this ship is added. So when here, where is it? Space dot add ship is called with that ship as a parameter. this will also have this called automatically, ship added. It's sort of like an event. So when the ship is added, we assign the space to the space member variable here, the space field, and now we can access it here. So here, when the destination is reached, we set a new course and to a random location, which we get from space dot get. Is it get random location or just random location? Space dot random location, and the speed we'll do it in is 0.2 again. Right, let me just check, erase that there. So now every time update is called, it will check whether it's at its destination. If so, set a new course, right? And then update its position and then draw itself at that position. So let's see. And they immediately start both doing it, of course, because it's now on every instance of the NPC ship class. We didn't only specifically do this for NPC1, the NPC1 variable or instance, whatever you want to call it. So they're all now, you know, moving randomly around. They'll go somewhere and then pick a new destination. Right, wonderful. So now lastly, the player class. We want that to also move around, but we want us to command it. For that, what can we do for that? So we also at least have to update the location every time in the update method, like we did for NPC ship here, update location. So we'll start with calling that anyway. Update location. That will do nothing, because, or not much at the moment, because, you know, if we run it, you can see the ship is still sitting there, because we don't set course at any point. What we want is, we want to click in the screen somewhere here, and the ship to set course for that coordinate that's under our mouse. So we'll start setting that up. Now, how can the ship know when the galaxy is clicked? When some place part of the galaxy is clicked? That's the question. Now, space class, space inherits from other classes. Basically, these are components. These are UI components that you can put on a frame. Remember that frame I showed you in the beginning, or show in a window? Those things can receive mouse events. So for example, on component here, in there, yeah, I just know these things. It's just things you have to learn about another way. You won't need to know all of this, because you're not going to really build your own application. You won't even use the run method really for modding TAXINAUT. I'm just all showing this to give you a kind of enough of information about how Java works, so you can write TAXINAUT mods, but you won't be running your own application, and you would certainly not be creating your own windows. Although you technically could in a mod to do that. Anyway, where was I? In the space class inherits from component indirectly, and component has some method called, we can add something to component, so we can, what is called, listen for the mouse events. It will forward mouse events to some other class that registers with it. This is called events. And it's in add, I think it's in here, add mouse listener. We can call that on a component. Now, space is a type of component, or is inherits from the component class. So add mouse listener is available on space. So what I'm going to do is, for the player ship, similar to the NPC ship, when it's added to the space, so on ship added, when that is called, we'll add it as a mouse listener to the space. You know, the space is a component, so we can call add mouse listener on it. So override source, override implement methods, ship added, the ship added event, remove this, and in here we do s.add mouse listener this. Because playership, I'm going to make it a mouse listener. Now this is red, of course, because playership isn't of class mouse listener. If we look at the documentation for add mouse listener, you can see already here the parameter has to be of class mouse listener or of type mouse listener. If I click now into mouse listener to go to its documentation, you can see here this is not a class. This is called an interface. Now an interface is just a different type in your application. So classes represent types in your application. Interfaces do too, but interfaces are different in that they don't have any code of themselves. They don't execute anything. What all they are is basically like a contract that says whatever inherits from me can do these things, but they actually do them themselves. I don't provide the code to do these things. So an interface will have methods defined on it. Like here it has mouse clicked, mouse entered, mouse exited, mouse pressed, mouse released, which will all be called in the proper situations, on the proper events, on anything that inherits from this mouse listener and has been added to a component, right? In our case, to the space component. So an interface is like a contract that you'll have to fulfill as a class when you inherit from it. And you'll have to provide what's called implementations or code for these methods. And to inherit from a interface, and inherit isn't really a good word, I'm using it anyway, you use the keyword implements. So it implements mouse listener. And then of course mouse listener as a type isn't recognized, cannot be resolved to a type, imported, right, that stuff. See, this now immediately accepts this. We can pass the instance of this class to as a mouse listener to the space. That's fine now. That doesn't. But there's a red thing here that says the type playership must implement the inherited abstract method mouse listener. Well, that's a whole mouthful to just say you have to adhere to the contract of mouse listener. You have to provide code for those methods that are defined on a mouse listener. Right, so we have to provide code for mouse click, mouse entered, mouse exited, mouse pressed, mouse released, etc. And we can just hover over here and go add unimplemented methods, and it will paste them all in here with little to-do comments in them, so you can put your own code for what's going to happen when these are called in there. Right, so I'll just remove all these to-do things because they annoy me. You can turn that off in Eclipse, but I'm working off a fresh install here, you know. I'm trying to make it exactly the way you would see it. So, so now, when we run this, of course, nothing happens yet because we haven't provided any code to happen on when the mouse is clicked. But as you can see, it all compiles, it's all fine. Whenever now a mouse click occurs on the space, playership will receive one of these calls here. So when the mouse is clicked, it will receive this. When the mouse is pressed down, it will receive this. When the mouse is released, the mouse button, it will receive, you know, this will be called on it. And we can decide in here by code what we'll do when that happens. So normally you would say mouse clicked, but yeah, that's just a side. It will make it feel less smooth because mouse clicked is only called when you press and then release the mouse button, and the mouse is still exactly over the same coordinate during that time. If you move your mouse even by 1 pixel during that press and release, it won't register as a mouse click. So it will make it feel kind of clunky, where it sometimes doesn't react, because when you press down on your mouse, you might push your mouse a little bit, and that might change the position between pushing down and releasing. So anyway, I'm going to use mouse released. and on mouse released, we're going to set a new course for the player ship. So we do again set course, because that's already defined on the ship class we extend from. Set course, and as destination, we'll use, as you can see, mouse released has a parameter called mouse event, and can be referenced throughout the code here through the variable e. So we'll go e dot get point, which returns the XY position of the event relative to the source component. Well, that's all a bit mumbo jumbo, but it returns the coordinate of where you clicked with the mouse, or where you released the mouse button. Get point, and we'll make the player ship go a bit slower, 0.1, half the speed of the NPC ships. Now we run it and we click somewhere. See, there it goes to our mouse, and then we can change one again, and we can change it halfway through, doesn't matter. Right, so I think this is a lot, but I hope maybe with rewatching the video a bit, maybe you'll have to watch it twice, you will get the basic elements of Java. The important part is that you kind of understand the inheritance, the using of methods on from a superclass, and the using of methods or implementation of methods from a interface that you implement. Because when you write a taxi mod, they will typically extend from some class that is provided by TAXINAUT, the mod will, or they will implement some method that TAXINAUT needs for your mod to implement. Like TAXINAUT will ask you to what planets do you want to add to the galaxy, basically, and it will have sort of a method for that in which you add your planets, right? Anyway, it's been long already, so I hope you've gained some insight, and I hope to see you again in the third video when we're going to actually create a TAXINAUT mod to add a planet to TAXINAUT. So thanks a lot for watching. Yeah, and see you next time.